Okay, so welcome to the GameSalad monthly meetup. Today we're going to be talking about graphics with Brian Hapgood, who is one of our senior engineers here, also our main graphics programmer for the GameSalad engine. Few little items to note before we get started. The next meetup is going to be a little bit flux date-wise. I'm kind of monkeying with a bit of dates to find a little bit better date that works here better in Austin. Again, I'd like to stress I'd love people to come out to the office. So far, we have had Ian now. We're going to have to eat 3 pizzas by ourselves. So we'd love for people to come help share the pizza and eat it. So if you're in Austin or you're close by, come down and see us. Also, I'd like to say that our public bug database is available at bugs.gamesalad.com. So you'll be able to see, for right now, I've actually put up all the bugs that are halting 11.1. So if you want to go take a look at that, you can watch me fix bugs for that. And we're going to go ahead and move all the stuff on the form that's on the public bug database. We are going to move that in there automatically. If you have something that bugged that's not on there, go ahead and add it to here. And this also has voting, so you can go vote for your favorite bugs. All right, so what we're going to do for question-wise, we're going to do questions at the end. And you can always type your questions up here, and we can, Brian, be able to see them. But we won't do any audio questions and such until the end. It just helps us with the recording. So I'm going to go ahead and turn it over to Brian here to start the presentation on graphics. Do you want to take it away?
All right, thanks. So I've been here a year now, and in that time had to get really down and dirty with the engine. And today I'm going to talk about all the new changes that are coming to GameSalad rendering. So, right, so the biggest improvements that come to the engine that deal with rendering performance and load time performance. I found in some pretty complex sideways scrollers, I've seen frame rates improve from 15 frames a second up to 60 frames a second. It really depends on how you author your art, so we'll get into that in a little bit. The other thing is that the load times are much improved over 11.1. Whereas before we would have lots of processing of the art when we loaded it from PNGs in your package or your APK. Now we have a sprite database that does all the processing offline and makes a really fast path to loading your art into your game. So what does that mean? That tends to mean that if you have a large game that is loading a lot of art, instead of preloading it up front, you're doing lots of on-demand loading. All that will be tremendously faster, especially on iPhone and desktops. Android's a little bit of a challenge, but we'll solve that. Okay, so with the new things, the new system, you need to really rethink how you approach your art. There's been I've seen a lot of examples of games where there was a lot of worrying going on in the file sizes of your JPEGs or your PNGs. In the new system, stop worrying about your image file sizes. The new sprite database will compress it all for you, and currently it stores everything uncompressed, but we'll be adding JPEG compression at a fairly small granular level in the database. So it doesn't buy you anything to worry about compressing your art in especially PNG Crunch or PNG, all these strange compressors that we've seen over the last few months. None of that helps you anymore. We do it for you. The second issue is get used to working on a 64 by 64 grid in Photoshop. Duplicate those 64 by 64 tiles as much as you can, because essentially what happens now is when our offline tool, the publishing, when you publish, the tool will rip your art up into those 64 by 64 tiles and will run through the whole image looking for duplicates of those tiles. So if you can stamp out those tiles on those grid boundaries, you're going to have a much smaller sprite in the database. For example, if you had a fully white background, then that would be one tile, as long as everything was pure white and there wasn't any gradients or anything like that. Then you get one tile instead of hundreds. Which brings me to the point of thinking about the way you build your art. Like if you've got I've seen one game where it was a full screen game, and it was just pictures. Every single screen was a different picture. Now, the best way to author a piece of art like that is this particular game had lots of lighting effects. They had really simple artwork that could be tiled really nicely, but then they flattened on top of the art a lighting effect. So you had this point light in the middle of the scene. That destroys tiling. You're much better off to make a very tileable image. Take your lighting effect as a separate image and layer that on top and multiply in the engine instead of baking it all down. It's better to have multiple images that have good tile use rather than one with lots of special effects and generating tons of tiles. The fewer tiles you have, the less memory it's going to take up at runtime. Then another issue that we saw is watch the size of your images, the image dimensions. There's a lot of in a lot of games I've seen, there's scale. All the art is scaled really big and authored really, really big, and then at runtime it's scaled down to the size that you want at runtime. That's the worst thing you can do in the new engine, because it will generate a lot of geometry. So the way that these tiles are put together at runtime is that we make it basically a triangle list, and we say, okay, there's a triangle quad there, another quad there, another quad there. They're referenced into a single bitmap. So all these little tiny pieces are loaded into one giant texture. That's so that we can draw the entire screen with a single draw call. But because of that geometry, if you have really large artwork, it's going to generate more of those 64 by 64 tiles. And the more tiles you have, the more geometry you need, which slows the renderer down. So it's always best to author at the size it's going to display at, or scale, or work at whatever resolution you want, but the final art that gets pulled into the engine needs to be basically in device scale. Okay, so as I've mentioned, we have a new cross-platform graphics engine. Uses a sprite database for really fast atomic loading on iOS and OS X. There's caching for Android because reading from an APK is incredibly slow. That's an issue with Android. Everything lives inside a compressed, glorified zip file, and so whenever you read files from that APK, it takes a long time. So we're putting a lot of effort into making Android work as fast as iOS. We're seeing really huge improvements in speed especially on iOS. So now, with these tiles that I talked about, we allocate up to 4 textures that are as big as the GPU can render them. So on iPhone 5, that's 4096 by 4096. What that means is one texture takes about 64 megabytes. But it's very careful in allocating those textures. If you don't use those textures, it won't allocate them. But if you have a really massive game, then it's gonna take all those sprites and all their tiles and put them into one texture, or spread them across 4 textures if it uses that many. It's pretty huge. So you can have in memory now, you can have 16,000 tiles. There's no more OpenGL version 1. That's gone away. So the code is a lot simpler now. Whereas before we had to maintain 2 renderers, one for GL1, one for GL2. Now it's just OpenGL ES2, and all the shaders are generated, so it's extremely flexible. No matter what platform you're running the engine on, it scans the hardware, figures out what GL extensions are available, and then turns on functionality, generates new shaders to work specifically for your hardware. So a lot of effort went into that. Like I mentioned, now the reason the engine gets all of its speed is there's a single draw call for all actors on the screen. If you have the same blend mode between every actor, then you'll get one draw call. Every time you change blend mode, like go to screen or add or normal and back and forth in your actors, then it will break the batch. So if I had, half of my actors were with normal blend and then the other half was screen blend, then you'd have 2 draw calls. But why are draw calls so important? Because the more you make, the slower your engine runs. And that's just the bottom line with GL rendering. So now with a single draw call, we can run at the theoretical limit of the GPU. Like as I mentioned, the renderer is highly adaptive now. Not only are the shaders generated based on what hardware you've got, but it also picks the best OpenGL extensions. So I'll use GL map buffer if it's available on Android. On iPhone, it'll use map buffer range so you're only flushing the bits that you use instead of the entire buffer, and lots of little optimizations like that. It's pretty cool. Bottom line is, it just runs a heck of a lot faster. So, talk about the sprite database a little bit more. All the incoming art, like I said, is ripped in these 64 by 64 tiles, and triangles are generated to render them. And again, the bigger the image, the slower the sprite runs. So you have to think a little bit more about your art, but it'll still run, but it depends on your game. If you're going for the utmost performance, then worry about your tiles. If you don't really care, it's a static screen that you're changing between screens, and it's not a sideways shooter or something, then you don't even have to worry about this. It all happens for you. You also now have, you'll never run out of memory, whereas before you could. If you had tried to load too many sprites at one time, you would run out of video memory eventually. Now you can't. What will happen is there'll be a big pause of about a quarter of a second as sprites are evicted from memory and all their tiles are loaded back off a disk. So it's constantly streaming from disk to memory and memory to video memory. So your games can be as big as you like, as long as they'll fit within the download limits of the platform. But we are working on that as well, so we'll have, hopefully we'll get to improving the Android download limit from 50 meg to 2 gigs. So we're working on that too. The other thing to talk about is when you're creating big art and scaling it down as you used to, if you really have to do that because you're worried about Retina, it's actually better to again author your art at the device resolution. So make it look good for a normal iPhone without Retina. Then use the @2x modifier in your file name. So you literally just at the end of your file name put @2x. That creates a second database that's specific just for Retina. And so then you can double the size of your image, and the engine knows is clever enough to know that it'll double the size of the tiles. So everything's still really fast, and all the duplication still works. And so you don't get, because if you jump to 128, if you don't jump to 128 square tiles, then you're just going to have crap loads of tiles when you really don't need that. The thing about the duplication, right now tiles are checked for duplication within the same image, the same PNG file. We will be working, the first version will just do it that way, but a later version will check for tiles throughout the entire database, so to bring the size of your database down as well. The other thing is the PNGs and JPEGs or Targas or whatever file format you're using will not be saved to the final package. Only the sprite database is. So there's no reason to spend any time optimizing those things. Just make them look good. And last option here is we will be JPEG compressing the tiles, giving you an option to JPEG compress all the tiles so that the download size is smaller, because that's a pretty important thing for a lot of games. Every tile, like I said, 64 by 64. It's RGBA, 32-bit per pixel. So it's a heck of a lot larger than a JPEG pixel. Under the hood, we create, if the hardware supports it, then we use ultra-fast vertex buffer objects, which is OpenGL speak for allocating a chunk of GPU memory for holding vertices. These are dynamic vertex buffer objects, or VBOs. So every frame we just run through our sprites that need to be displayed, clip sprites out that are not visible on screen yet, and then just append those to the VBO and just dynamically update it. On Android, we use something called GL map buffer, which returns a pointer to the video memory, and you write straight to it. But they're on older machines. It will fall back to allocating its own buffers and using the slower GL. I can't remember the name of it, but you can basically update a VBO in one go, which is really slow. On iOS, it uses the iOS range, map range APIs, which are extensions supported on everything from iPhone 4 up. There's a lot of work gone into Android OpenGL, because Android GL is not as well implemented. The driver is not as well implemented as it is on iOS. Even on 3.0 hardware, you can't access those extra features from GLES2. Even in cases where it says there's an extension that exists, for example, to do GL map buffer, on a lot of older machines, it will actually fail. So it'll say, oh yeah, I do GL map buffer, but it's lying to you. So there's actually a small database inside the engine now, so we detect the name of the device, the chipset of the device that we're using, and we'll scale the engine based on model number. So a lot of effort's gone into that to make sure that we scale, get the most speed possible from the device it's running on. The tile memory usage, memory footprint on disk is much larger. Like I said, each scene can allocate up to 4096 by 4096 on an iPhone 5, or an iPhone 4 is 2048. So it basically queries GL and says, what's the biggest texture I can make, and it allocates that. On an iPhone 5, you lose 64 meg right off the bat. So, and if you end up allocating all 4 megatextures, then that ends up being 256 meg that you'll lose from your 1 gig. On an iPhone 4, it's a little bit more unpleasant because you only have 512 meg to start with, and you can lose half to your sprites now. We'll keep on playing with heuristics to make that less painful, maybe providing an interface to control that. There's 16,384 tiles that you can have loaded at once. If you try to allocate the 16,385th, it'll be loaded from disk, and the oldest tiles will then get evicted from memory. So it's constantly streaming, new replacing old tiles until. And if you go back and use the same tiles, then it'll reload it from disk if it isn't in memory. And so you have to think a lot about your reuse on large maps. You want to have hard point. You want to load as much as you can in the start of your level, and then have load points where you can load more artwork. Because you want to avoid the pauses that you get from accessing the disk. On Android and OS X, there's an extra feature where we dynamically resize the megatextures. So on those platforms, it'll start out with a megatexture of 512 by 512. Load the tiles into it. Oh, I've run out of space. Then it'll resize the tile, the megatexture. That's a really great way of minimizing wasted memory on these textures. Unfortunately, you can't do it on iPhone. So iPhone, you start out and you only have one sprite with one tile in it. You've lost 64 megs. Whereas on Android and the desktop, you'll only lose a few meg. The reason for that is there's a bug I found out that there's a bug in iOS's GL driver, so that GL text subimage 2D, which is an API for copying pixels down to a texture from main memory. You call it too much and you pass too many tiles down to it after you've resized it and all this. It actually fails to flush the buffers, so those tiles never get copied. So the only way to avoid that is to not resize tiling, do resize tiling on iPhone, which is really annoying. But anyway, so here's a screenshot of our game Raptor Storm. And so right here you just see the title, dinosaurs, and on the next screen I'll show you how it's actually broken up into tiles. So right here you can see the background is all single tiles, and then you see where it says test build, it's actually broken the test build up into tiles as well, and so those tiles are displayed on top. In memory, this is what it looks like. So you see lots and lots of pieces just stacked one after another in memory. And you can see that, you know, all the little pieces for the background for Raptor Storm and a previous animation that played in that game. Yeah, you see all the artwork right there. And we've got, as you can see, we've got tons and tons of space left over for more tiles. Every scene in the engine has its own a set of mega textures. So if you change scene and go to a completely different scene, then you'll have to reload. All the loading goes into the new texture. So there's no sharing between scenes. That's an important thing to remember. So you're going to get a load hit every time you change a scene. Our shaders are adaptive as well. Like I said, they're all generated in code, and one shader is used amongst all the batches being rendered. So the engine boots up, generates its shader, and it uses it from then on in. It has many different strategies for making the shaders run as fast as possible, because a lot of your frame rate is going to disappear based on which instructions you use. On an iPhone 4, we use arrays of textures, whereas on iPhone 5, that's slower than using conditionals. So iPhone 5 and above, we use if statements in the shader to select which mega texture you're going to display, or which mega texture that tile is going to go onto. So conditionals are much faster on new hardware. Android uses conditionals because though texture arrays are faster, not all devices support them. And I've actually run into bugs on Android where OpenGL fails to compile anything with an array in it. I've actually had GL link program just stop and never return and get into an infinite loop because I had an array in the shader. So we only use conditionals on Android. Conditionals on old hardware, like I say, it's about 20 FPS for a big sideways scroller compared to 60 on newer devices. But there's nothing I can do about it because of the limitations of GL on Android, especially on pre-3.0 devices. So here's an example of a vertex shader that's been generated by the code. So it just grabs a position, saves off the color and the UV. And then this is the Android pixel shader, or fragment shader, I should say, where the Z component of the UV contains which texture to use, and that's how we are able to have multiple, have tons of like a big vertex buffer full of different triangles, and every single triangle can select a unique mega texture to display from, so that we can pack all of those textures. Could be different sizes on Android and OS X. So that's the pixel shader right there. The special diff, the final else in that list of if statements is to handle white untextured actors. But we have other ways of doing that on the other platform, on the other types of shader. So that's about it. That's my little presentation.
Thanks for joining us. Next month we'll have education. So if you're a teacher or student and you want to talk about education, send me a message on the forum. So let me know.
Or if you know the school or a teacher who wants to talk, just let them know about the meetups.
Yep. And you don't have to be here in Austin. We can do remote presentations.